Okay, welcome to a little talk about React and Flux. I'm very glad you're all here, and my name is Johan Bergens. I work for 1337 in Stockholm. I've been here for about a year now. I'm mostly doing C# and JavaScript development. And this talk, I know you have different backgrounds and know some of you know a bit about React already, and some have tried it and some has just heard about it. So, and we're also recording this, so some people who see this has not heard about React. So I will go very quickly over what React is in the beginning, and then I will go into the more advanced stuff like Flux and Flux frameworks and explain what those are. And then I will show some code samples. The first samples will be very easy and very small. And then I will start to show some code from our current projects. So it was okay with our client to show that some of that code. So I can, you can ask me questions and I can get into code and show some more things. And we'll see, I'll probably be around an hour. So, and after that, if someone wants to say, I can be here also if you want to do some experimentation yourself with your computers. It's very easy. So what is React? It's a JavaScript library. Someone said it's the V in the MVC. It's just the view part. It's created by Facebook, and they made it to develop single-page application. And nowadays, most new projects that I see, they want to do single-page applications. And it is a really good reason. When you have single-page applications, you can do two things. You can do more advanced things with animation and other stuff and updating the screen. And you can also separate the front end from the back end and use something like a REST server, REST API, and talk to that. And that actually makes the code better because you have the back end that manages data and storing the data in database and stuff like that and querying the data. And then you have the front end which is more occupied with showing information, showing the screens and forms and whatever you need. And it's actually very good to have these things in different parts. And they have some goals when they created React. They said they was going to use it for building large applications with data that changes over time. And I will get back to why this is, how they reached this goal. And they have some more ideas inside of this. They said we're going to use JavaScript, and we're going to use something they call single direction data flow. And they wanted to make debugging easy, at least easier. And that's very nice because my last project was with Angular and a lot of asynchronous code and Angular and a lot of things. It was very hard to debug, and that made the whole project take a lot more time than I anticipated. So, yes, some people have asked me, how is React when you compare it to Angular? And actually, I've used React now for about 6 months, I think, but I used Angular for like 18 months. So I assume I should be better with Angular, but I have forgotten a lot of things about it. But the things I do remember is when you compare React, it's less things to learn. It's much easier, it's much smaller, and that's very nice when you get into it. And it's faster for most things. And then Google, who has made Angular, has started with Angular 2. And Angular 2 is like a complete rewrite. They changed everything inside of Angular. So if you made an app with Angular 1 and then you want to go to Angular 2, you have to rewrite large part of the app and you have to learn a new API again. So they change things a lot. And it's for the better. Angular 2 looks much nicer than Angular 1, but it is a burden to have to rewrite apps and learn new APIs again. It will take a lot of time. And I think React is easier to learn and it looks more stable. And of course, they're not really in the 1.0 version yet. So it might change a little bit. And they have some things that they say this is a little bit still in discussion how they're going to do with this and parts of the API. But most of the things are very stable. And compared to Angular, React code is much easier to combine with other JavaScript code. It's more like a library where you can write things and then you're calling the library instead of a framework where you have to write code that matches what they expect you to write. So of course you have that. I would say that React is a framework also. You have to do code and it has to match their API. But since it's a smaller API and you're mostly involved in the view things, you can do all other things any way you want, just JavaScript, or using something that compiles to JavaScript, which are a lot of languages nowadays. So if you want to use CoffeeScript or TypeScript or something other, it's totally possible to do that. So says not a framework. I would say it's kind of a framework with React anyway, but it's a much smaller framework at least. And it's very usable now, unlike Angular 2, which is not ready. It's in, I don't remember if it's alpha version or technical preview or something, so it's not even in beta version yet. And then we go into components. Angular, they had components, but they had components of different kinds. So they had directives, and then they have controllers, and then they have services, and then they have templates, and you have to learn all these things and how they fit together. In React, you basically have one thing, and that's components. Everything is components. So that's very easy to understand. And now I'm going to go into React and explain a little bit more about what components are and how they look. And they are the building block of React, and you can nest components. Components is something that writes to the screen. You can say you're going to create a view with data. You're going to have an application, and you're going to have a view and then information on the screen, and it has components on it. And the components can have smaller components inside of them, and everything works together to render something. And components are very easy. They just render data and execute some view logic and try to avoid other things. But it is JavaScript classes, so you can do whatever you want. If you want to place all your application logic inside one component, you can do so, but that's your problem. Other logic, if you want to do logic, you can just write normal JavaScript classes and call them. It's no problem. And one thing people always react to when they see React the first time, it's JSX. And that means you basically have something that looks like HTML inside the JavaScript. And it's first time you look at this, it's very, very strange. But when you start to use it, feels very natural, because you create a small component that's supposed to render some HTML. For example, you're going to do a div with a P element inside and some text inside the P. So that's div P and some text, so you probably get some from some JavaScript variable. And then it's very natural to just write this out like HTML and just put here the variable. And then it looks like most templating languages. And there are a lot of templating languages like handlebars and everything. But in React, you use JSX instead, so you don't have a normal templating language. You just have JavaScript with JSX. And JSX is actually a separate standard, so it's not a requirement. You can do React without it, and you can use JSX for other things, except React if you want to. And a little bit more about some concept for components. They own state. You have to create an application, and you usually want some state and some information to be known and be kept as long as the user is working with it. And this component holds this state, at least here in the beginning. We get into some more advanced things then later. And then you send data to the components as properties. And properties is the components when you use them. They look just like HTML. It's like tags and then normal HTML properties. So it's the same way. You just write them out and add properties. And you can declare the types of the properties using something called prop types. And if you have properties that are changed, or actually have state inside the component that changes, the component will rewrite itself. So it will render itself to the screen again. And this is a nice thing, because what React does is that it basically says you have to set up the state how you want it to be, and then it just renders everything to the screen for you. So when something changes, if you have a list, for example, the to-do list, everyone sees the to-do list, then you have a small list of things to do. If you add a new thing in the list, you just have to add it in the list and say, tell React to render this list. And it will notice that it says the same list with one more thing, and just add that inside the DOM tree in the browser. And that's very nice. So that takes a lot of the complexity with creating user interfaces away from you. So just, this is a state, and here is how I map one state to some kind of view. And that's all you have to do. State, and then you map it, and then you get the view out. So it's kind of functional, actually. And if you go into a little larger application, then you can use the Flux framework or a Flux pattern. So it's kind of a design pattern, actually. And then you have main state, and you say, if you want to have a lot of state in the application, maybe it shouldn't be in the components. So then you can use Flux instead, and then you have the state in something called a store. So store has state. and then you combine the store and the components. So this is what React thinks. Componentize everything, all the things. And some other things. I already mentioned JSX, and I just mentioned Flux. So React is one thing, but to use it, and some people, when they compare it to Angular, they said you are missing a lot of things. But actually, I'm not thinking you're missing a lot of important things, because for handling more state, you can use Flux or some similar things like Redux or Reflux. And if you want to use a router, you have something called React routers. You can just include that and use it. If you want to build your own router, it's possible to do that also. It's very easy. So we'll go back to those, and I will show some example of how they are used. So now I have to see if I can find my first example. Here it is. I have to look here because I can't really read the screen from this angle. So here's a very small application. And I actually took down a tutorial or something, just made a few small changes to it. I'll see if this works. So here I have, and by the way, I'm using ECMAScript 2015 or ECMAScript 6, sometimes it was called before. And that's basically because we're using that in our project. We tried it and we thought it was quite nice to have things like fat arrow and let and other things. So, and then we also have classes, so we're using class, the class keyword here. In this, I'm using this in this demo, we're using that in our project. I'm not really sure you need that, or if you don't want to use class, it's possible to use React without it. They support ECMAScript 6 with class and ECMAScript 5 without class. So it's very easy to choose. The code looks a little bit different, and I will probably most show the ECMAScript 2015 version. So here I have a component called a counter, an extends component, and component is from React. So here is a import, and import is also from ECMAScript 2015. Otherwise, you might have something like require or so. And that's also something. I won't go into all the details, but if you're going to use React, you probably will use build script like gulp or grunt and browserify or webpack. So I think I have one demo that uses webpack, and then we have another, our normal project uses browserify and gulp. So that's just a choice to you. Just take something and learn how to use it. But you probably want to write your components in different files, one file for each component most of the time. Sometimes 2 or 3 components in the file, but most of the times one component in every file. And then you need to combine those, and that's very nice to use something like browserify to do that, or webpack. So, okay, so I have a component called counter. It extends the component from React here. And then I have constructor here. So, and here I have something called a state. So here I have something called a counter, and I initialize that to 0. So this is just an hash or an object in JavaScript. So counter is 0. And here I have some other things. Actually, I was supposed to have only one thing here, but I have another method here. And here I was showing some problems with the ECMAScript 2015. There's a lot of helper libraries that can help you write a little bit shorter code to manage this, or do it automatically for you. But if you don't, so here I have a tick method. And actually that works anyway, but here I have a stop tick, and I want to clear this into using the this variable here. And in ECMAScript 2015, you don't get, you're not bound to this. So if you don't do like something like this, here I bind, stop tick bind this, and assign that to stop tick. If you don't do it, the method will not know what this is when you run it. And that's not something with React, it's ECMAScript who does that. So it's something you have to learn. And then you see something else here. The tick thing here will just change the state. You're doing a set state and then change the counter, and it actually uses the old counter, and then it adds something here called increment from props. So we can see if we can try to run this example. Where am I? Now I never remember. No. Yeah, it seemed to have worked. Now I should have a small web server. This is using a Node web server, and it should have wired everything up and said that for development I want to use a small server just so I can see all examples and things. And then I will go over here and see if I can find this. Yes, there it is. A counter, and it's counting. Actually, it's 2. So, everyone has seen the counter. It's very, very beautiful. It was not my example from the beginning. So if we go down here, where did that came from? So in the end here, I have something export class app. So this is like the boot part for this small application. So this is actually a component in itself. And here it only has one thing. It has a render method. It has normal small components only has render. It's all they do. To say when you call this component, it should render out some HTML. And here you see the JSX. So this div, it looks like HTML, but actually it isn't. It's small differences from HTML, but it's very close. And then you have here counter. This is the component that was above this. If you go up in the code here. Here I have the counter component. So here I have everything in one file just to make it very easy to see where the code is. So I say I want to use one counter, and I send this increment thing to it and set it to 2. And then I have a color here that's nice. And then I had another counter that says increment to 5 and color super nice. And those are just imports so I got from something from colors. So I don't have to go into what the colors are. But if we go back here, when you have this, when you write it like this, so this, I said this should increase this counter, increment it with 2 each time it increments. So now I just changed that. So I say, okay, we should just increment it with 1 instead. And I should, yes. Yeah, it's incrementing 1. So, okay, we say increment with 3. Now it's incrementing with 3. And here I'm also showing something that's a little bit funny, because the reason why I started the server, it's set up using something called hot reload. So what it does, it reloads JavaScript on the fly. So when I save the file, it reloads it and actually keeps the state. So the counter was incrementing even though I changed the source code. So it's very nice. It keeps state in memory, then it reads the new file, and then it applies it. So I actually don't use it for my normal work, but it looks very nice. And I think you could use it for a lot of things, because then it's very easy, very fast flow. You can change things, and then you can see the result directly instead of waiting or compiling and doing everything. So it's really, really quick. So, for example, if I just write something here like hi, it was not the best, and I say that, and now it says hi. So it's very, very easy to use, and this counter is still counting. I will stop it because I get tired of it. So that's something, the React hot loader, you don't have to use it, but it exists, and you kind of want to use it. You need more or less to use Webpack with it. So if you know what Webpack is, then you can look this up, or if you want to learn, you can read more about Webpack and this hot reloader thing. But you can, of course, just use normal gulp script and build the files and then refresh the browser by pressing F5. But if you do that, all state will be gone because you're reloading the page and JavaScript disappears. So, some more details here. What really happens? So I have a component. It usually has some render method, and here I can see in this counter thing, it does a div, and then h1, and then here it has some style information. And here you can see these curly braces. And that means that within these curly braces, it's actually JavaScript. It's just normal JavaScript. So here I just said, actually within this first curly brace is JavaScript. So this means that here I send it an object, a JavaScript object, or like a hash that has the color set to this value, this props.color. And props, that's the properties thing. So that's what this component got when it was called in the beginning. So here the app component calls the counter component, and here it sends the increment property to 3 or 5 or whatever it is. Or here the color component sets something. So here I see props color, so this is the same thing like this. And somewhere here I have props increment, and this is this thing. So that's what's, it's just passing information here into this, and here inside I'm using the information. And properties are supposed to be set from the outside and then not changed from the inside. You just get them and then you use them. So that's like functional programming. You get information and then you do something and return results. You don't change the input. The state is something that's internal inside the components. So that's the other way around. You can change it anyway, anytime you want, but you don't send the state out. You just use it internally. So in this case, I have the state, I have the counter thing, and I'm using this here, state counter. So here I say the counter has some value here. You can see if I can make this. No. A little bit easier. So here is the counter, and then it has the increment thing there, and here is the counter number. And you see this, it sets counter. If I want to change something, I can say counter here. And here it says counter here. It changes directly. So. And then you have this, and here you just have these curly braces again. And in this part, it's just text. Will be just text on the HTML page. And here I say curly brace and props increment, so it just uses the props. So I take the variable, which is an integer in this case, or a number, and I place it with this, in these parentheses, but I could just write it without them if I want to. Counter is, if I want to do it like that, it will say counter is 3. But actually this is the increment, so it's like this. I go back. Times. So the times is not really correct. So if we go through it again, you have the render method. Actually can do things. It's a JavaScript method, and then a function, and then it returns something, and it should return one thing. That's a strange thing with React, as one of the few limitations you have. You should return just one thing. That means another component, or possibly a list. So you can return a list of other components if you want to. And when you do like this, using the JSX, so this div here, it will be like a component, an HTML component, kind of. So this is, okay, I will have a div component, and inside that I will have a few different things here. So I'm just returning one component, and that's okay. If I do something more here, I will get an error. If I say that. And here also, in this hot loader setup, it actually renders a page with some error information. So here it says, you have something strange here. You have here div and then another thing. And if you go through everything, it will probably say a little bit more about, here it probably says something about this error. So you have more things than one component, more than one return value or result value. So I just remove it and resave it, and it should be working again. So the component has a render method. The render method usually returns another component or HTML component. And inside here you can use curly braces, and then you can call props, this props, or here this state. And state you have to, the component has to manage its state itself. And it's usually just an object or a hash with information inside it. And then we go down to something more here. In this case, I have the onClick. Here I have a button, I have onClick. And what React does, it catches events. It actually has a virtual event system. We don't have to go into all the details how it does it, but it's really nice because then it can get events from different things and collect them further up in the DOM tree. It's good for performance to do that. And here it has something, so it's a onClick for this button. That means you should call this stop tick. And here you have it called braces again. So basically you're sending it a function. Say the onClick for this button is this JavaScript function. Just do whatever you call that whenever someone clicks this button. And if I'm going to go up here to the stop tick, as I have actually goes with clear interval, this interval. And this interval is set from the beginning in the constructor here. I have this line. I said this interval is, and set interval is in JavaScript. So this, and here I'm using the fat arrow, by the way, on Lambda. So I say set interval, and here I say this is a little method that we call the tick every 1 second or 1,000 milliseconds. So every second it should call the tick method. And then it save this because then I can clean it up afterwards. So I don't say anything more. This is all I do. I say call tick once every second, and tick just to set state and changes the state here. And then I don't do anything more because React will know that if you change the state, it has to re-render itself. So the component will write itself out again, and it will try to optimize itself, will not change anything that you haven't. See if this, yes, it works. That you haven't changed. So as you see, it works really great. So you just say, yeah, the state now is like this, and it will re-render. I'm not sure how fast it is. I can try to see if we speed things up a bit. Now it's, no, probably didn't have time to redo everything. I haven't tried that one before. Okay. So now we have seen a simple component, and as I said, React is components all the way down. So basically you know React now. And some more things about components. They have life cycle, so we have the render method, it will render itself. And then it has some helper things, so component will mount and component did mount. It's called, before it attaches itself to the DOM tree, it's how it works internally. And will unmount, that's very good because here you usually clean up after yourself. So in this case I have an interval, so then I can remove that. Using this, when it's unmounted, it means it will be removed from the DOM tree. And then it should probably not do this every second anymore when it's not visible. And it has something will update and should update. And the will update, it's called when someone sells properties to the components. If someone sends new properties to it, you say, oh, I got new properties, I need to re-render myself, and then this method or this function will be called, and you can do some things inside there. So that also means if you want to get external data, you could do it in the will mount, or you could do it in the will update, or other places. Or you could actually do it in the render. So for each render, you could call a web server or something. But the render has to finish. You shouldn't do asynchronous things inside the render. It's much better to do it in the will mount and say when it returns, then you just change the state. And if you change the state, it will re-render itself anyway. So if you want to write components and call the server, you can write components and call the server directly from the components. That's not something you usually do, but if you want to, you can do that. If you're going to create an application, then you usually need a router, and the router connects routes to components, and that means how you browse into an application. And it can actually, the React router can match a hierarchy of components. You can say, I can show an example of this. You can say that when you go into the /products, you go to the product list component. But if you go to product/1, then you maybe go to the product details component instead and show that, show just one. And then you can actually have more things below that and say, okay, if you have product/1/ subcomponents, I'm not sure what you want under the products, license, for example, maybe some special information, then the router can, you started with this products1 part, and that means we're going to show the product details page. But then you had something more. That means we probably use a specific component inside of that other part. So this is like a subcomponent in the view. It's hard to understand, but it will be easier if I show it. So we can go into Reflux to do MVC, actually using the router. So I will start by just showing the router. This is made by our colleague, Michael Brasman from 1347. And this is also a small example, and it's available. You can search for it, the Reflux to do MVC, and you will find it on GitHub. And here I think I have it. And here you have one file with a lot of things inside, and actually we go into the components, I think, first. And here it has a lot of things. So here is the to-do item component, and then it does some things, and here it says it's render itself as an LE element, list item. And here it has to-do main component, and here is actually using ECMAScript 5. You're using something called React Create Class. So this is not the 2015 version. And here also using property type that's saying that list is something this component it wants to have. It has a property called list, and people who calls this should set the list. And it should be an array with objects inside it. And the required thing here is required. It means you have to call it with this, otherwise React will complain. And it has a render component, a render method or function. So here was the interesting part. So to do app here is the kind of bootstrap thing. There's also components as usual, and it has a render method. And also when you're using this create class, you usually send in like an object. So it has key and then the function. So render and then the function. So it's the same way when we had a render function inside a class before, but this is another way to write it when using the ECMAScript 5. So to-do app has a render, and the render will return this div with 3 things inside it. The to-do header, and here it uses the router and route handler, and then the footer. So it has a header, and then the route handler will do something, and then you have the footer. And if I go down here, actually here I see when he configures the router, so you say he has routes, and I think this is the old one. They changed the API a little bit, so the names are different if you use the newer React router, but it's, the documentation is updated, so you can see what it should look like. The React router routes, and here it says, yes, if you don't have anything at all, it just said go to the app. And here it says the path / if you just go to the, then go to the to-do main. So it will always go to the app, and then it will go to the main component, if you just go to the root part of this application. If you go to the /completed here, it will do, just use it to do main again. So here it actually uses the same thing in all cases. So that means the to do main probably has logic inside it that looks at the current route and see where you try to go and what should it do now. But you could call different components here and say, when you go here, go to this component, and when you go there, go to that component instead. So you can do a lot of things. And we can see if we can start this one also. I should probably stop the other one. Maybe I did. See if I have. No. I hope it was this one. No, I think this is. So, the to-do app. So, here we have it. It works. If I click here, I can remove things. Say all, then I say I have done those. Maybe we have ruled the web also. So if I say all, I say active or completed, so it filters the list, the normal to do MVC. And I can clear those and go back to all, and I show this one. And here, I didn't show you here. Here you have go into the root part of this. If I go to active, you see it changes. This is what the router does. It looks at the URL of the page, and then it sends that into the component and chooses components to show. So here I can go around. And this is just normal single page application things. You usually have a router. It's the same page all the time. It just goes up and down, add things here to the URL and changes things on the page. So, any questions so far? It's been a lot of things.
I have a question.
Okay.
You just said about reflux, but you didn't say what flux is.
No, it's so many things to go through.
Okay.
But we'll get to that in about 1 minute, I think. Where did I have other thing? Here. Maybe I'm not going to show this right now. You have developer tools. So you have developer tools from React, and then there are developer tools of some of the Flux frameworks. So the React developer tools, that means you can go in and have that in Chrome, and you can inspect the component hierarchy. So you can view a web page with React code on it, and then you can see what components are used in this page. And that's very nice for debugging and looking at what it does. Now I go into state and external data and Flux. What is Flux? Flux is a pattern. It was created by Facebook, so it's like a design pattern. When you create this larger application, you don't want to keep all state inside small components. And if you try to do it inside the components, after a while the components has to talk to each other and then pass state around, and you get a lot of problems keeping a lot of different states or state in different places and trying to sync those things. And that's really hard, and a lot of system has problem when where do you keep state and how do you connect the state to the view and to other logic. So they thought about this and they created Flux, and it's separate from the components, but it talks to the components. And Flux itself doesn't really say that you have to use React. It's more a pattern how you can do things. And what they have is they have stores. Stores handle the top level logic and the state for the application. The store responds to action, and when it gets an action, it changes its state. So the component had its state inside of itself. The store has its state also. It's just a separate thing that has state. And components can call or create an action, whatever you call it, and then the action will be sent to the store after a while, and the store will react on this action and do something, updates its own state. And when it finished with updating, it can tell all components that subscribes to it that, yes, my state has changed. This is the new state. And then all components who subscribes to this state, this store, it gets the new state and they can re-render themselves. So that's a very easy way. So that means you can have some information that you want to change from some part, but then you want this change to be visible on multiple parts of the page at the same time. That means you have like 3 or 4 components that subscribe to the same store, and they will all get this update and they will re-render themselves. And it's so fast, so normally you don't see it's JavaScript is single-threaded, so it of course will send it to one component and it will re-render itself, and to another it will re-render itself, etc. But when you look at it, it looks like all parts updates at the same time. So it works really, really great. And it's much easier to talk about saying, yeah, I have a store and the store has state, and then have some actions sending things to this. And they tried to explain this a little bit better here with some little graphics. So here we have this action and dispatcher and store. And I haven't mentioned the dispatcher. And this image is from the Facebook Flux website. They created a website for Flux. You can go in and read all they have to say about it. But basically, action is something that says we want to do something, and they send it to something called a dispatcher. And in some Flux frameworks, you have the dispatcher and looks at and sees it. And we have used a Flux framework that's called alt, like alternative, alt.js. And in that, you actually don't see the dispatcher. You just send an action that it will be taken care of. But then it will appear in the store. It's very nice. So action sends to the dispatcher, it goes to the store, and the store updates the viewed ID component. If the view has a button or something that wants to change something, it will send a new action. And this action will go to the dispatcher, who will send it to store. And the store will change, and all things that needs to know about this will get to know about it. And of course, it could be different stores and different components. So if I have one action and you get down, and you're to the dispatcher, to the store, and to a view or component. The component renders itself, and then the user is using this application and clicks on a button. And this button causes an action to be created. And the action is created and sent away. And this goes to the dispatcher, and then it can go to another store. And that store will be updated. And all components who subscribes to that store will get the new information. So what they say is this like a flow, it goes round and round. But having this single going just one way, it makes it much easier to understand what happened, much easier to reason about what will happen. And when you do create bugs in your application, you can see, yeah, I got here, and then I got to this part, and then something happened and it didn't work. And that makes it much easier. If you have asynchronous code and a lot of code, and some code are calling some other code, and this code is calling that code, and then everything starts to do asynchronous, then you don't know which order they will be called, or the callbacks will get back. And it's really, really hard to debug those things. But here you try to go down to saying, yeah, but this thing will always go like this. So usually when you have something that's asynchronous, it's somewhere around the action or action creator, action generator, you should call them, that does something, and then when it gets back, you get the action, and then you go here again. So here you call something else, and you do a synchronous thing, and then you get back an action, and then continues. And that means if you want to debug this, all you have to do is basically saying, you always have one dispatcher in the system, so that's a singleton. So if you can debug on this or log on this, then you will see all actions and what order they get called into the dispatcher. And that's much easier to see, okay, what happened? Yeah, I got this, got 5 from this part, and then I got 6 from another part here. And okay, then as a developer, you can say that was wrong. You should have gotten in the other order, or maybe it should be a 7 also. Then that's the 7 part has got lost, so that you never got that action at all. So then you can start to see what happened. And it's hard to understand Flux when you just look at it like this. And they have some version here with this same picture with some more information. And some technical details. Every action is actually sent to all the stores. But the stores usually, they subscribe or register with the dispatcher. So the stores tell the dispatcher, I want to listen to these kinds of actions. And store methods are kind of atomic. So when you're inside the store, you usually just update the state, and then you're done. So that means you can update multiple parts of the store's state in one go. And you know that no one else can, you don't have threads. You know, thread can go in and change things in the middle. So you know you got an action, you do some things, multiple things, and then you're done. And then you send out this event and saying that the store state has changed for total subscriber, and all the changes will be done. So this works really well it will be a problem if you have multiple stores that are connected to each other. And the different Flux libraries have different ways to solve this problem. So usually I have something called wait for or similar that says, yeah, I need to wait for this other store to be done before I can do what I want to do. So then it just say, put me in the back of the queue and go do the other thing, and then I wait, and when it's done, then I continue and do whatever I want to do. But when you do that, then you can get into some situation that's a little harder to understand the code and what happens. So you try to avoid that unless you need it. So also when you have async things, you usually use a pattern that's like if you have find orders action. So the first thing you do, if this is asynchronous, you're calling a server with find orders, you just do an action called find orders, and then when it gets back from the server, then you call find orders down, so you have another action. So they're actually different actions. So the first action don't have any data, just said we have started this find order thing. So for example, you can create a spinner or something, a loading icon, say this is something is happening in this application, we are calling the server and we're waiting for response. If you don't want to do that, you don't have to use this at all, but it's a very common pattern. So find order, and then you say find orders done when it's done. If it doesn't work, the server may be responding with an error, or it doesn't respond at all and you time out, then you usually call something find orders fail. And then it's up to the store will say this, and all the components that subscribe to the store will get some information. And usually what you do is you set some kind of error state, and the components can say, okay, we have the error state is now, maybe you have an error flag, and then the error flag is set, and then you just show the error message. So it's very, very easy. The code is very clean. So, and I'm currently working for a company called Techies, and we are using the Altered JS. We get into Universal JS later. We have created we are actually creating a small application. And I have this open here. So this is what I'm working with for the moment. And I'm very sorry, this is Swedish. And actually the source code is in Swedish also. So you will have to learn Swedish really fast. But I think you can understand. This is kind of something we call reports. So you have different reports here. And I can see, okay, and here I have something in the Sundbyberg actually. And I can open that and I can view it and I see some information, and then can go, yes, I want to change this. I want to change this number to like this. And as soon as I moved away here, I got this thing. So here, actually, I was calling a store that kept information about what record are we using here, what record are we showing and editing. And then it also has some kind of view information or view state things that says, okay, have we changed this record yet? And when I say, yes, now I've changed it, then we got this. So if I restart this, so here I have 497, and I changed it to this and tab away, and here, those got there. And that's one way we're using this store, because this is one component, and the other thing, this is another component or different components. So we want to say, okay, we have a dirty flag, we have made something, and we want multiple components to be aware of this. And that's a very good reason to use a store, to have state as, for the application, for a large part of the application that multiple components need to have. If it was just one single page with things, then you could have that as state information inside one component, if you want to. And that's also one thing I really like with React, because you can choose a lot of things how you create your code. Do you want to keep state inside your components, or want to use state in stores? And sometimes you want to do one version, and sometimes you want to do the other version. And you can pretty much choose whatever you like. So it's more up to the developer to choose what's the best way in this situation. What should I do? React doesn't really say. So here, just saving. Okay, and if we try to do something fun here. So I started the normal developer tools in Chrome, and here I actually have some things. So here I try if this works. And actually I have different things happens on the timer, so it will get new rows here. I can hide this, or we can see it. I can do like this, and I want to send here debug page I have. No, it didn't work. Maybe I need to reload, refresh it. It has log here. So it should. No, it didn't. It worked an hour ago, so I'm not sure why it. Yeah. I'll try to get back to that later. Maybe it's some error or something. It has some error here. But what it can do when it works, I haven't used this much. Then it can show all the actions that you get in. So this is like a debug tool, so you can see the actions, and then you can see what information that you're sending to all parts of the applications. So I'm sorry it didn't work. We can do like this instead. Here I have something. So now this says 31. It says I have 31 new items for something. This application subscribed to a server part, and it checks for new information. So it polls. I think it's every minute or maybe every 30 seconds in this developer version. So here I can just do like this, for example. And this thing incremented, and it also did a small animation. So if we want to look at that code just for this thing, that's a small thing. Here. So now I'm inside this application, and I have something called SOS counter store here. So this little thing here. And we're using the alt from alt Flux. And so the store is basically just a class. So I say, here I have some, this is the number, antal nya, or the number of new items. And then it has some other things. And here it says bind actions. So it will say this store is interested in the counter, so SOS counter actions things, those actions. So I bind to those. And that's basically all I need to do when I'm using alt. And then I create functions. So here I have a function fetch antal nya done. So that's the done part. That's when I fetch something, it will get here. And it will just match it on the name. And in the normal Flux version from Facebook, you usually use kind of global static variables or constants. So long strings that you see, okay, this is more or less unique, and then you match on those and use switch statements. But this is easier actually, I think. So just different ways to do this. So here it says, if I get some information here, I will do some checks for this, and I will update this thing. I just set this to 0 if it gets new data at all. And here I have some logging. And that's basically all it does. So if we go into this action part, here. And here can add some more log information. Maybe I need to do that to get the logger to work. The dev2 logger. So here I have a class for the actions, and in the end of the file I will call this alt create actions. So here I say I need a component, and the component will be created by this using this class as a base, and then it will add some new things to it, and I export that, so I will use that later. So this thing here says generate actions. So here I have this fetch antal nya done, and that's just a name. I just said there's an action we can call from somewhere, and the store should know that. And this is all I have to do. I generate action for it here, and then in the store I subscribe, and then I can use it. So normally what you do from the code is you call this fetch antal nya. So this is like a public function or method on this action thing. So this is called from some component, say now it's time to check, and then it's just dispatched. So it will just say this, and that's the beginning, the first thing. And here I am calling the server. The resource thing here is we'll do an HTTP request to the server, check for new messages or new data, and when it gets back, it will call this fetch until nya done and send in the data. And I have a catch here, so if something doesn't work out as it should, then I will call this fetch until nya failed. So it's very clean code, very easy to read, and you know what happens. And that means the store will just have different methods. So it will say the done or the failed and say what it should do. And the component that uses this will just have to say, okay, what state do you have and what do you want to do? So see if I have this here. So here I have something, there's an interval thing that goes out every 30 seconds something, and it says call this counter action fetch until nya, and it actually sends a time. It wants to know if are there any new messages since the last time I checked, and it keeps its own state when it checked the last time, and then it just sends that. So here the actions is something that's the thing we looked at before. So I'm just saying I'm using this from the counter action file, get that and use it. So I'm calling that, it will call the action will call the server, and it will dispatch itself, and then when it gets response from the server, it will dispatch again and say it's done. And the store will update itself, and when it has updated itself, it will tell all things that subscribes to it that now you have new data and you can show that. And that's what's happening. So when I click this, the number here should go up. So it goes round. So basically this button isn't really connected to this, it just goes call the action, and the action calls round all the way. Yeah, so I think we have been doing this for a while now. So we should try to... It didn't work when I wanted to show it, but I have used it a little bit, so you can make it work. I don't know why it stopped working. And I will try to wrap this up a little bit, because we have spent an hour or so already. But some things to know about this Flux. There are many different implementations of Flux. Flux is like a design pattern. And you have the Facebook original. And actually, they didn't release that. When they released the Flux design pattern, they didn't release the Flux implementation. They had that internally for a while, for a few months. And that meant a lot of other people started to create Flux implementations, say, okay, what do they mean? It's like this. And they had like 15 different implementations. And all developers try to look at this and say, which implementation do I like, and is it maintained, and is the code nice and everything? And it's really hard to show, but it has settled down a little bit. So now this one, Alt.js, it's easy to use, and that's one of the most common one. So that's one we are using right now. And this is quite common also, the Reflux by our colleague Mikael Brassman. It's actually easier to use, but it's different. It's not really following the Flux pattern exactly. So he simplified things a lot, and it's really nice. It's very easy to get started with this, but it's not the same as the other Flux implementations. So it's good to know that if you want to use it. So if you're going to do a small React implementation, I would say Flux is the easiest way to start if you want to use some kind of Flux. And then you have a lot of different other things. And then we have even more, so Redux and Baobab. The Redux uses a single store. You don't have small stores. You have one store with all the state for the application inside the store. And then you do, it's like a functional programming. Then you do map and filter and reduce on this store to use it and change it. So in the normal Flux, you have a store, and the store has a function or method, and the method will update the state. In Redux, you have a reducer instead, and reducer is a function that says, if I have this state, and then I will change it, and then you will get this new state instead. So that's what the reducer does. So basically the store is just the state after the reducer has done everything. So when you call action, it's just actually calling a reducer. Just call the reducer will change the state. And then it will tell everyone to update with a new state. So it's hard to understand really quickly, but it's very interesting, and it's gaining a lot of momentum right now, and a lot of developers are looking at it and started to use it. We have one small project inside with the same client. They have tried to use it, and it worked really great for that. So we are thinking about rewriting to it, but I'm not sure if we're going to rewrite everything or we'll wait. And then we have the GraphQL, and I don't have time to go into the GraphQL. That's a separate thing. It's like a query language. So you can create queries for the server and say, I want this information from the server, and it will get the information and put it inside the store. And another, that's also a single store like the Redux. And then they update the component. But the special thing with this is that the actual queries, they are written inside the component. So the component can write, here is a query, I want this data from the server. And it will just work. It will get the data after a little while if the server has the data. And that means you connect the component with the data it needs, and the query for the data very easily. So that's very interesting. And there are other things also. Yeah, I already said that. So we didn't have time to go into the container components, but as you know, when you have a lot of code, you usually want to divide the code in small parts and say, well, this part takes care of this thing. And sometimes you use the single responsibility principle and say every part of the code should do just one thing. And that means a component shouldn't call the server, get information, and then re-render itself. That's a lot of things. So when you need to do things like that, you usually use container components. So the container calls the server, gets information, and then it just passes the information down to another component, a child component. And the child component just said, I have some properties, send information in these properties, and I will render a view, some information on the screen. And that means it's very easy to test this inner component because it's pure. It takes values in the properties and then renders information. And you can try that, do a TDD or unit test for it and see if it works. And if it works, all it takes data and renders output. Then it should continue to work. It's no logic. More than maybe than saying if this is 5, then I show another div or something. But very easy. And that means you also can do these components, the small components can be more reusable, because if you place it in another part of the application, it will just render itself when it gets data. It doesn't care where it gets its data from, because it's the container that gets the data. And you can use immutable data, another thing we didn't have time to go into. And that's basically for performance optimizations. React is really fast by itself, but if you want to make it even faster, you should use immutable data. Because then what it does is try to look into the properties it gets and say, okay, do I have the same properties as the last time? Then I don't need to re-render myself. If all I'm going to do is write like the counter thing on the screen, this was text and some div and the tags, and then it was the number that it got from the property. If the property is still 5, like it was this last time, then it doesn't have to re-render anything. If the DOM tree is already created, it can just reuse it. So just leave it as it is. But that means it has to compare this 5 and the next time see if it's still 5. And for numbers it's very easy, but if you send in larger components, so maybe in our case we have something called reports. So if I send in a report, it's much harder to do this comparison. Is this report the same as the last report? And our reports are actually like hashes or objects with multiple levels of information inside them. So React by itself only does a shallow comparison. It doesn't really look into the parts. And that's a problem for something. Well, if you want to do it really fast and you have immutable data, then you can just do a reference comparison and say, if the references are the same, then it is the same thing. Then you don't have to do anything more. Just comparing 2 pointers, more or less, like 2 integers. That's really fast. And another interesting thing, you can use React on the server. So you can use a node server and run JavaScript on your server, and you can use React there. And then you just write it more or less the same way, but you create HTML and then you send that back to the browser, just like a normal web server, ASP.NET MVC or something. But the nice thing is you can do it with React code. So if you learn React, then you can use React for doing single-page application or for doing normal web application like all other languages if you want to. And this universal JavaScript or isomorphic JavaScript, that means you create JavaScript, usually React or other things, that creates an application or an interface, but you can use the same JavaScript on the server and on the client. And that means you can do things like also for performance optimization and some search engine optimization, for example. So you can say if some user is browsing to the server, and it's the first time they just browse to the server and they send a URL with some information, then the server can look at this URL, render the UI, what it should look like, and send this HTML back to the client, just like a normal web server, and it will be very fast and the client will see it. But what you also send back, if you do universal JavaScript, is that you send back the React code and the JavaScript needed to update this user interface. And then it takes over. So then when it's downloaded on the client, the React and the React application takes over, and then it's a single-page application from that point on. So it has the state, it has its information, and then it starts to work as a single-page application. And it can call the server for more information for REST interfaces or something like that. So you have some more possibilities to do some optimizations if you want to. And Facebook has also created React Native as a way to build native iOS application and also native Android applications. So what you basically do is you use in React and you change a little bit. You don't create HTML, but you use some other view components. And those components are created so they match the components or the user interface components inside the operating system, for example, phone. And that means you can create a native application. It will be a native application with a normal looking user interface. But most of your code is JavaScript and React. And that means you can reuse this. A lot of the code, not all the code, but a lot of code, you can reuse it and create an Android application and an iOS application, actually a web application also. And that's very nice to have a part of the code base be the same on all platforms. And the last thing is a lot of other frameworks are taking some ideas from React because they're really good ideas. So I hope you have seen a little bit what it can do. And just to sum things up, I think React is really great. I haven't found a great weakness inside of it yet. And that's the thing I think is most interesting, because when things are released as frameworks or libraries and developers, oh, this is new, I want to try this out. And after a few months, people usually say that, no, okay, I tried it was really good for something, but not for everything. It was not a silver bullet. And of course, React is not a silver bullet either, but I think it's the best of all the user interface frameworks I've used for creating web applications so far. Maybe Elm is better, but Elm is a very different language. It's very hard to sell into a client to use. But it's really, really nice. And you can do a lot of advanced things, and you can have some clean code while you do this. And you can combine with other libraries with React. So for example, you have different Flux implementation. I think it's good that you have a few different implementations to choose from. Then you're not stuck in one of them. I think that's the best way to do it. And like the router, if you need a router, there is a router. You can download it and use it. But if you don't like the router or not need a router, you don't have to. You can write your own or just skip the routing thing altogether if you want to. And it's quite fast by default. We haven't done any optimization, and if you notice when I clicked things, it didn't really take much time to do anything. So, yes. And here I have some references. I think that's all for today. Thank you.